Alright, time to prove this once and for all. We have the Earth here. Okay, this ball, it is on a piece of string like the guy said in the demonstration. I've got to give him credit for that because that was a good little demonstration. And we have the pole star at the top. The Earth lines up every year, all year for thousands of years to that pole star. Same with the southern pole star. It always aligns. It never comes out of alignment. Now, if that line is always a continuous line, how does the ball get to the other side of that line, or how does the Earth get to the other side of the ball without going out of alignment? It can't. It physically cannot. It proves absolute, without a doubt, that the ball has to move to get on the other side of that pole. Not only that, that pole is always a straight line. Doesn't matter where you go around it, it is always a straight line. The problem with it is the sun angle changes off that line. That proves the sun moves. Okay, it spins around the Earth. Anyway, thank you for watching.
So many wrong things in this video, but we can address only 4 points. Point 1. The scale of this huge universe. Point 2. The angles over distance. Point 3. The real position of Polaris. Point 4. The visibility of the pole stars, especially the southern one. Let's address point 1. Here we compare the size of the Earth with the size of the Sun. And here we compare the size of the Sun to the size of Polaris. And in the next video we zoom out from the Sun to get Polaris into view. Now, if we graph the distance the Earth will travel compared to the distance to Polaris, the distance the Earth will travel won't be even visible with the naked eye anymore. So let's get to point 2. Keep a lookout for the windmills in the far distance for the next 20 seconds during this train ride. I did plot it out on Google Maps and I will turn it upside down to get a schoolbook style triangle. This way it's easier to understand for, everybody. I know, Jesla said.
My mind is like a supercomputer.
So I imagine that his brain will be like... Now we will do some calculations, so get your calculators out and the idiots will go into full panic mode.
What is that? What is that? Oh, that thing has numbers on it.
So let's draw it into a picture. From the train we see a windmill in the distance. A train of this type has a travel speed of 100 kilometers an hour. So 100 divided by 3600 and times 20 again gives us 0.556 kilometers. From the last position, the distance to the windmill is 2.343 kilometers. And the angle compared to the train track is 90 degrees. The invertebrate of the distance train traveled over 20 seconds divided by the distance to the windmill is 13.50 degrees. So here's the Google Maps with the... Oh sorry, it's still upside down. Let's turn it around. So here is the Google Maps with the distance and angles in numbers. Even though he completely misunderstands the position of Polaris, we're still gonna use it to do some calculations. Here we see the maximum and minimum distance to the Sun. We will concentrate on 2021. If we take the distance to the Sun in the winter together with the distance to the Sun in the summer, divide that to the distance of Polaris converted to kilometers, we get a very small angle. That will look like the whole train video, but then 400 billion times slower. That brings us to point 3. Okay, let's get the almanac and get the bearing to Polaris at the perihelion. And there it is. So here we have the bearing to Polaris. The distance to the Sun and the direction to the Sun. We get the straight line in there to represent the orbit and one in a 90-degree angle to have a reference. And here we have the correct tilt. So now we subtract the angle of Polaris from 90 degrees and subtract that number from the tilt. And we get the tilt to Polaris. Now when we have those numbers, we have to jump 6 months into the future. And there we are. Now we have the bearing of Polaris during the aphelion. The distance and the direction. So we put in the baseline for the orbit again and the 90-degree reference line. And again the tilt of the Earth. Now we do the same equations as before. and we can insert the tilt to Polaris during this time. And if we subtract the aphelion from perihelion, we get an angle of 0 degrees and 0.4 minutes. That is less than 7,000ths of a degree. Even though that angle is so small you cannot notice it with the naked eye, it is 159 times bigger and proves Polaris moves. Fourth and final point. Northern, Southern, Northern, Southern, Northern, Southern. Polaris is just very close to our northern rotation point. The star close to the southern rotation point is hardly even visible, even with the correct equipment. I am not a scientist. I'm just a merchant navy captain that knows the world is an oblate spheroid due to my job. I got one more fact for you, and that is that ships stay afloat due to buoyancy and density, and that things fall down and stay down is due to something else.
This is called gravity.